This lecture is on the conservation of momentum. Some of the most powerful concepts in science are called the conservation laws. This was covered in detail in the energy unit. So if you need more information about that, go ahead and re-look at those lecture notes. Here's a summary of what we covered then. For conservation laws, it applies to closed systems where the objects only interact with each other and nothing else. They also enable us to solve problems without worrying about the details of the event itself. In the last unit, we learned that energy is conserved. Like energy, momentum is also a conserved property of nature. This means that momentum cannot be created, it cannot be destroyed. The total momentum in a closed system is always the same. The only way the momentum of a system can change is if momentum is added or taken away by an outside force. We will use the conservation of momentum to explain and predict the motion of a system of objects. As with energy, it will only be necessary to compare the system at two times, before the event takes place and after the event takes place. The momentum of an object changes when it experiences an impulse. An impulse is the force dotted with the elapsed time. Impulse is a vector quantity because force is a vector quantity. This means that the initial momentum we start with, plus any impulse that is given to the object or the system, then gives us the final momentum of the object or in the system. This impulse arises when a non-zero external force acts on the object. This is exactly the same for a system of objects. So if we have the momentum of a system we start with, plus any impulse that occurs in the system, that equals the momentum of the system at the end or after the event takes place. If there's no external force acting on the system, then the net force is zero, and that means the impulse is zero. In that case, the momentum I start with has to equal the momentum I end with. In other words, momentum is conserved. So let's go ahead and do an example. I want you to go ahead and try to answer this question before going on in the video. Why don't the internal forces on a system change the momentum of the system? So go ahead and pause and write down your answer now. Okay, let's see if you have it right. The internal forces result from the interaction of the objects within the system. By Newton's third law, these are all called action-reaction pairs. And viewed from outside the system, they actually cancel each other out. Thus, there is no net force acting on the system, and momentum is then conserved. An external positive force acts on a system of objects. Which of the following is true? There's two answers that you need to select. Is it A, the velocity of the system remains the same, B, the velocity of the system increases, C, the momentum of the system decreases, D, the momentum of the system increases? Pause now and select your answer. Okay, let's see if you chose the correct answer. The correct answers are B and D. If you have a question, go ahead and write that down or put a little question mark and let me know on Edmodo. In the next lecture, we're going to talk about types of collisions.